An overview of a hypothesis test. Suppose someone claims that the proportion of left-handed students at a certain campus is at least 0.2 or 20%. These are the percentage of students who are left-handed. Do not worry how we obtain some of the values in the following steps. The goal of this video is to introduce the four main steps of a hypothesis test. We will go over the detail in future videos. For the hypothesis test, the first step is to state the claims. A hypothesis test is a formal procedure. Think of it as a court trial. In a court, they do not say, "We assume the defendant is innocent." That is not the statement that they would use. They would say, "We assume the defendant not guilty." And that is the statement of indifference. The hypothesis test is the test against the no hypothesis. The no hypothesis or the no claim is the statement of indifference, and so whether they mention at least or at most, the no is always equals. So this is 20%. The alternative is the proportion of left-handed is less than 20%. Don't worry about how we get to this statement less than. We will go in depth further. The next step is to collect and summarize the data. Remember that the claim is about the entire population. We assume that 20% of all students are left-handed. From this population, we're going to pick a representative sample and we would collect the data. We ask, are you left-handed? The proportion of left-handed will be the number of left-handed out of the sample size n. And to summarize this, we compute what we call the test statistics. We rely on the sampling distribution when we carry out the test, so we assume normality. In the middle is the assumed value of the proportion of the population 0.2. Assuming that we ask 83 students in this sample that we obtain, and also assume that 10 of those students answer yes, they are left-handed, then the proportion of the sample is 10 over 83 or 0.12 rounded to 2 decimal places. And we see that 0.12, the proportion of the sample, is on the left-hand side of the assumed parameter p equals 0.2. We compute the test statistic z for the proportion because we want to see how far it is from the mean using the standard normal distribution. Then we assess the evidence by computing the p-value. This is the probability that we would get such at extreme values, assuming that the no value is true. We get a p-value of 0.0342 in this case. Then we compare this to the significance level. Usually, the significance level is 0.05 unless stated otherwise. This p-value, if it is small, then we would reject the no hypothesis, small meaning it is less than the significant level alpha. If the p-value is greater than or equal to the significant level, then we would fail to reject the no hypothesis. And from this, we would make the conclusion. We make the conclusion based on the evidence that we found, based on the sample that we collected. And in this case, the p-value is less than the standard alpha 0.05, so we would reject the null hypothesis. Again, the hypothesis test is the test against the null hypothesis, and so the smaller the p-value, the more significant the test. For small p-value, we say that the result is statistically significant. And it's not quite surprising here because the smaller the p-value, meaning the data we collect is further away from the center, and if it is further away from the center, then it is rare, it is unusual. As the result, the small p-value tells us that the data we collect is nowhere near the center, And that is why when we assume the null hypothesis is at the center and the data that we collected is so far away from it, then we say, well, that result is not close to what we assumed. It is so far from what we assumed that we have to reject it. Keep in mind that the null hypothesis is the statement of indifference where we assume that the proportion of left-handed students is 0.02. But if we were to reject the null hypothesis, then we would have to informally accept the other claim, which is the alternative. And the alternative claim is that the left-handed proportion is less than 0.2. Again, if we reject one, we would informally accept the other. And so in this case, we would reject the null hypothesis because of the small p-value. We conclude that the proportion of left-handed students is less than 0.2 in this case. Assuming that, again, the null hypothesis is true, when we carry out the test, we reject the initial claim here because the initial claim is that the proportion of left-handed is at least 20%, but we found that the proportion of left-handed is less than 0.12%, and 0.12 is not greater than or equal to 20%. We conclude that this initial claim is invalid. And so again, the hypothesis test is used to determine the validity of a claim.